Hey everybody, thanks for joining me today. We're going to get into simplifying with combining like terms and distributing, and then we're going to have to do both. These two particular topics fit together really well because usually when you distribute a number of different things in the same problem, when it's all done you're going to have to combine anyway. So hopefully this should go together really well and we'll be able to get this done and maybe pick up a couple of tricks along the way on some of those problems that people commonly miss. So let's start with combining like terms, such as the 5x and the 4x, and hopefully you know by now that 5x and 4x makes 9x. And then you've got a positive 3, so you have $3, but then you owe $5. That means you are $2 short. So your final answer here would be 9x minus 2. All right, example number 2, we've got an x squared in here. We don't have a lot that we can do with the x squared, so we're just going to leave it as x squared. There's nothing to combine it with. If we had 2x squared plus 5x squared, you'd have 7x squared, but in this case, that's not what's happening here. Now, you also have 3x minus 2x. If I have 3 of something and I take 2 away, I still have 1. I'm not going to bother writing the 1 in general. We prefer to just write it as x. And then you've got a negative 4 and a positive 9. So in this case, you owe somebody $4, but you have 9. That's good news because you can pay them back and you'll still have $5 left over. All right, we look over here to example number 3, and I purposely threw in a bunch of different variables just to emphasize the point that when you are combining your like terms, you can't combine different variables. So you can't add a and b together and get something like ab. That would be if you multiplied. But if we're just combining like terms, you can't do it. You're just going to have to leave it a plus b. And as we dealt with in example number 2, you also can't combine x squared with x. You have to leave them separate as well. So pay close attention as we go. We have a plus 4a, which looks a lot like 5a to me. The 3b is all by itself. I don't have any other b's in this particular problem, so we'll just leave it. And then we go through, and it looks to me like we have a negative 5c and then a negative c. So if you owe 5 and then you owe 1 more, now you owe 6. So we've got negative 6c. So all these different variables, they're not meant to really mean anything. It's just to emphasize the point that you can't combine them. All right, let's move on here and actually start distributing here. We've got 3x times x. X times x is x squared. So that means 3x times x is going to be 3x squared. And then you've got 3x times negative 9, which is going to be negative 27x. We don't have anything else we can do with it from here, so we'll just leave it there. All right. I addressed this in a prior video. You may or may not have seen it, but whenever you have a problem written like this, a lot of times you will see it on a worksheet, and it was pretty much written that way just to see if you were going to get stumped or not. The truth of the matter is multiplication is commutative, which means it doesn't matter what order you write it in. So this problem is actually just a very standard distributing problem. You're going to take negative 2 times y squared, negative 2 times 3y, and then negative 2 times negative 5, which would give you a positive 10. So it was written differently just to see if it would mess anybody up. But the truth of the matter is, you treat it just like any other problem. All right, example number 6, you've got a negative 1 in front. Make sure you know that that's a negative 1. A lot of times when you put a negative in front and you don't put the number 1 next to it, it just gets sort of lost in the shuffle. People just don't recognize that you have to distribute it, but you do. So make sure you identify that as like a negative 1. Whether or not you actually write out the negative 1, I'm not too worried about that, but I do want to make sure you understand what's going on. Now, whenever you multiply something by a negative 1, that's going to change every sign on the inside. which means initially the first term was positive, now it will be negative. And then initially the second and third terms were negative, so now they will be positive. All right, when we get to these examples down here, you are expected to do both distributing and combining like terms as well. So don't forget that's a -1 like we just talked about. And that will give you 4x squared plus 36x minus 1x, and I'm just going to write x right there. And then -1 times 7 is -7. Now when we're done and it's time to combine things, the 4x squared is all by itself. I have nothing to go with the 4x squared, so I'll just leave it. 36 minus 1 is positive 35. So if I have 36 x's and then I take 1 away, I still have 35. And then the -7, there's nothing to do with that one either. So we'll just go with that. Example 8. I'll be honest, when I first was going over this problem and getting ready to talk about it, I didn't really notice that one of the variables was an x and one was a y, which is kind of silly if you consider the fact that I was the one that wrote the worksheet in the first place, but you know, it happens. It's really easy to not notice when variables change. So don't be like me, make sure you actually get this one right. So we've got -9x, there's nothing to go with that. And we've got a -9y, and there's nothing to go with that. The only thing that can be combined in this problem is a 45 with another 45. And then that would make 90. So your final answer when it's all said and done would actually be -9x minus 9y plus 90. All right, example 9. Just to frustrate people, if you ever want to make a high school student cry, just give them fractions. I don't know, it's one of those weird things that in 6th grade, I think you were probably better at it than you are now. Unless you're watching this video and you are in 6th grade, at which time, keep up the good work. Anyway, it looks to me like we've got a bunch of fractions here just to annoy you. Let's see what happens to them in the end. We've got a 1/2 x minus a 1/2 x. So 1/2 x right here. Then you're taking away 1/2 x. Wait a second, that means you got no x's. 1/2 x minus 1/2 x is nothing. Now in this case, you don't have to write 0x. Just leave it alone because there will be something else at the end of the problem. We have a positive 1/2 and another positive 1/2. And that part, unlike the x's, which went away, the 1/2 and the 1/2 will make 1. All right, so let's get to example number 10. Find the mistake, describe it, and correct the error. And this is happening more and more on standardized testing nowadays. A lot of you may be dealing with that sort of thing, where they make you not just do the math, but describe what you're doing. A lot of this multiple choice testing it is still there in some form, but now there is a description to go with it. So what happened here? Well, it looks to me like we did 15 times x, which is 15x, and then we did 15 times 5, which is 70. Yeah, it looks to me like the problem here is that the 15 was multiplied by the x, but the 15 was not multiplied by the 5. So what is the problem? Well, find the mistake, describe it, and correct the error. The 15 was not distributed to the 5 in the second term. Now, it said we also have to correct the error, which means we have to actually write out what the problem should have been. So let's just write that out here. If you took 15 and you multiplied it by the quantity x plus 5, you would get, hopefully, 15x plus not 5, but 75. So that would be how we would actually correct this and demonstrate the distributive property. All right, last example right here. -2 times x is -2x. Check. Negative 2 times negative 3, a negative times a negative is a, oh. It should have been positive 6. All right, so describe what just happened. Well, the negative 2 should have been distributed to the negative 3 to make 6. It should have been a positive 6 because we had a negative times a negative. All right, so if we actually wanted to correct this error, you would take the negative 2 times the quantity x minus 3, and then you have to make sure that that negative sign gets distributed to both terms, which would give me negative 2x plus 6. So that would be the error that needed corrected. We need to make sure the second term in the end turns out positive. All right. I appreciate your time. Thanks for joining me. Good luck the rest of the way.